Whenever we sketch an angle on the coordinate plane, there is a designated place to start. So first of all, let's start with that. If we're going to draw a 60-degree angle, knowing that we have a coordinate plane here, first of all, we have to know where to start. And we're going to start right here on this side of the x-axis, the positive side of the x-axis. That's always the first place to start. Now we're going to go up 60 degrees and we can kind of eyeball it. We know what a 60-degree angle looks like. And it ends up looking about like that, and it opens in this direction. It always opens in a counterclockwise direction. Counterclockwise meaning it is the opposite direction that a clock runs. So it's going to go like this. Let me remove these two magnets before they distract you any further. They look like eyeballs, but they're not. Okay, the next one is a 120-degree angle. And when we sketch a 120-degree angle, we still start at the same place. And that place, of course, is right here. So that's the beginning of it. But let's keep in mind a couple things. Let's notice that this is really 0 degrees. And that this, of course, is 90 degrees, because you can kind of tell it makes a little box. And this is a straight angle. That would be 180 degrees. And for what it matters, we don't need this yet, but that's 270. We add 90 every time. So in order to graph 120 degrees, of course, it would be between 90 and 180. This one is pretty self-explanatory as well. You know what a 120-degree angle looks like. It's about like that. It opens in this direction. Doesn't have to be exactly there, but it's somewhere along those lines. Okay, for the next one, it's a 185-degree angle, and you can probably already tell where it is. We're used to angles that only go to 180 degrees, and so because of that, we're not quite accustomed to angles that are larger than 180. So we have 185 degrees that we're dealing with here. And knowing that we have 185 degrees and that this is 180, it's going to swing all the way around here. So it starts there, it swings all the way around, and then it comes down a little bit further, meaning that it goes a little bit beyond a 180-degree angle. So it's about like that. Now when we look at it from this perspective, it's an obtuse angle. So if we were just to kind of piece it together from here, considering this, it's obtuse. But with this, it's even bigger than a straight angle. It's more than 180 degrees. Next one, 110. This one's not too bad. I believe you got this. So 110 degrees. Always starts here, goes up to 90, and then a little bit more. So it's somewhere along in here. It's pretty close to where the 120-degree angle was, but not quite as far. So that's a 110-degree angle. Now, the next row, they're going to get a little bit crazier, particularly towards the end. So let's just go ahead and draw each of them. So 250, knowing that this is 180 and this is 270, then 250 is going to start here, and it's going to swing all the way around past 180 and almost get to 270. So 250 is somewhere along in here. And for what it matters, it opens in this direction. Something that's bugging me that I should do. That's a degree symbol right there. There we go. Okay, next one, 270 degrees. You can probably already tell where this one's going to go. So 270 degrees, you can kind of see it directly above it. Here we go. This one actually makes a right angle in a sense. That swings all the way back around 90, 180, 270. Now, if this is getting a little bit boring to you, trust me, I'm going somewhere with this. Okay, 360. Here we go, 360. Now it's starting to get a little more interesting. A 360-degree angle. Keep in mind that this, of course, is 0 degrees. This is 90. Stating the obvious, we add 90 each time. 180, 270. And then if we were to add 90 again, we would come back around to 360 degrees. So a 360-degree angle starts here, and it would swing all the way around, all the way back around, and it would come back and land in the exact same spot. So it actually is just one ray that goes in one direction. Okay, now it gets really interesting. We have a 365-degree angle. We have a degree for every day of the year. Okay, starts in the same place. And now what we need to do is go 365 degrees. So it starts, it goes 360 degrees, so it turns one complete circle, and then it cycles back around and it comes up 5 more degrees. So it's that. Now I drew it a little bit larger than it should be. That's bigger than a 5-degree angle, but let's go with it. So it started, it swung all the way around, and it landed there. Okay, I want you to keep in mind that a 365-degree angle is equivalent to a 5-degree angle, because it went 360 degrees and then 5 more. So a 365-degree angle and a 5-degree angle are really the same angle. They're going to end up in the exact same spot. They have the same, what's called a terminating ray. They end in the same place. Okay, so for the next few problems, they're going to start looking a little bit more like that. I'm about to erase this entire board, so if you need anything, now would be a good time to pause the video. Well, that one's not wanting to come off now, is it? Okay. Here we go. Now we have a 725-degree angle. Now, let's state the obvious. We know that it starts here. And let's be realistic. We know it swings around the circle at least once. We know that much. So we know that when we draw this thing, it's going to go 360 degrees. So now the question is, how much more does it go? And there's an easy way to find it. So let's do it. Let's pretend like we've already gone one whole circle, and that would be 360 degrees. And when we subtract 725 minus 360, of course, we get 365. Well, a 365-degree angle, let's see. Well, if we have a 365-degree angle, and we just did this problem, but just to prove a point, let's keep going. We would swing around the circle 360 degrees, and it really gives us a 5-degree angle. So a 725-degree angle would swing around the circle 2 whole times and end up in the same position as a 5-degree angle. So it's pretty much the same as the last problem. Now, you don't have to do this next part, but just to demonstrate, let me show you. It started 360 degrees. It went again, that's 720, and then 5 more degrees. So it swung around the circle twice. A 585-degree angle. Okay, let's just stop before we even draw the coordinate plane. You already have yours on your paper, but a 585-degree angle obviously is bigger than 360 degrees. Knowing that it's larger than 360 degrees, we need to figure out what it really corresponds to. Since it's too big, let's subtract. So let's subtract 360 from 585, and of course we get 225. So we're going to subtract 360, and we get 225 degrees. So this angle is equivalent to this angle. They have the same value, and they end up at the same place if you graph it on a coordinate plane. So starts there, wherever 225 is, so 0, 90, 180, 270, so it's between these two. Actually, if you really want to be technical about it, it's exactly in between these two, exactly halfway in between. It would swing around one time, and then end up there. And again, you don't have to draw this little swirl, but I'm doing that just to kind of demonstrate what really happens. Starts there, swings all the way around, and then swings 225 more degrees. Okay, now we have a negative angle, negative 60 degrees. Well, obviously, this one would not go in the counterclockwise direction. Instead, it's going to go in a negative direction, so it's going to go clockwise. So instead of going 60 degrees, it's going to go negative 60 degrees. Still starts in the same place, but now it's going to go down 60. So instead of me going up, it's going to go down 60 degrees. And so that's what it looks like. But let me demonstrate something for you. This is obviously not between 0 and 360. So it's not a normal angle that we would consider like we did at the very beginning of this worksheet. So we need to get this number to be between 0 and 360, so let's add 360 degrees to it. And when we do that, we end up with a 300-degree angle. So this angle right here is the exact same as if we would have graphed a 300-degree angle. If the next problem said graph a 300-degree angle, it would look exactly the same as this. The little arrow inside would swing around the other way, but it would look exactly the same. Okay, the next one is negative 100 degrees. So before we go any further, let's realize that this, first of all, is not going to go counterclockwise. It's going to go clockwise if we're going to follow the negative, but let's not even do that. Let's do this instead. I want to know what angle this corresponds to. It really corresponds to a 260-degree angle because they're the exact same thing. So let's graph that. $260 would be right about there somewhere, probably a little further, but that's close enough. I'm going to stop drawing the angles of the little arrows in the middle, showing you which way it's turning. Okay, there are 4 more problems. We're going to go through these rather quickly, and then I'm going to give you a couple definitions. Well, one definition and an explanation. 1005. Oh, way too big. Way too big. So here's the trick. We know it's too big. 1005 is much bigger than it needs to be. Since it's too big, let's subtract 360. So we're going to subtract 360 from that. When we subtract 360, 1005 minus 360, we get 645. Okay, still too big. We need a 360-degree angle, or less. We need to be between 0 and 360. We do 645 minus 360. We get 285. We really have the equivalent of a 285-degree angle. There we go. 285 is going to start here. Goes to 90, 180, 270, and then a little bit more to 285. So it's somewhere around in here-ish. Not perfect, but there it is. That's what it looks like. Okay, don't let this next one throw you off. 3,600-degree angle. Whoa, we're going to have to subtract a whole lot, aren't we? No, don't even subtract. Forget it. Don't subtract. That's pointless. It's a waste of time. No need to subtract. Wait a second. I just wrote 3,600. I really wrote 360, right? I'm proving a point here. That's 360 with an extra 0. Let me ask a silly question. Does 3,600 divide by 360 evenly? You bet it does. It goes 10 times. What that really means is a 3,600-degree angle means that I would really make 10 revolutions around the circle. 360, 720, 1,000 and... my mind just went blank. Let me see. Hold on, I got this. 360, 720, 360, my goodness. 360, 720, 1,080, and then I'd keep adding 360. I'm sorry, I had a little, my mind went blank, brain fart. I'd keep going around and around 10 times. Long story short, here's what it is. Because it divides by 360, it's the equivalent of going around 10 times, and it ends at the exact same place. Right there. Okay. 2 more problems, and then we'll give you a couple explanations and definitions. I think I can squeeze them in this blank space I've created up here. Negative 760. Negative 760 degrees. Okay, too big or too small? Too small. Because again, and I'm going to write this kind of down in the corner. We want this to be between, terrible handwriting, we want it to be between 0 and 360. Now, it could include either of those. Another way of saying it, and I'm going to kind of write it in a more mathematical way. I want it to be between 0 and 360, but assuming this would be some angle theta. theta is between those. And, you know, it could equal one or the other, so let's just let it equal 0. It could be 0, or it could be less than 360. It's greater than 0 or equal to 0 and less than 360. So really, this is what we're looking for. So in good plain math language, this is it. Is negative 760 between those two? Oh, absolutely not. So what we need to do is add 360 as many times as we need to get it, because it's too small. So we'll add 360, and we end up with negative 400. Okay, well that's still too small. So we have negative 400, and then we add 360, and we get negative 40, and that's still too small. We have negative 40 degrees. Goodness, we want it to be in here, and it's not. So we have negative 40, and we add 360, and sure enough, now, there it is, 320 degrees. We have a 320 degree angle. It falls in between 0 and 360, so we're good to go. There we go. Starts here, 90, 180, 270, and then a little bit more, around about there somewhere. Okay. Negative 800. Too big or too small? Ah, right, too small. I hope you said too small. Add 360 to that. We wind up with negative 440. We have negative 440. We add 360 to that. Negative 440 plus 360. And we have negative 80. Still too small? Yeah, too small. Negative 80 plus 360 degrees. At this point we should be able to do this in our head. This should be 280 degrees. 280 degree angle. Okay, I hope you realize, and here's the main point. I hope you realize, the axis is crooked. That's not what I want you to realize. That these are equivalent. If you were to type in your calculator the sine of negative 800, the sine of negative 440, sine of negative 80, and the sine of 280, you would get the exact same value. They're the exact same thing. I'm going to demonstrate that in just a minute, but let me draw this one first. Okay, so it swings up 90, 180, 270, and then just a little more, so about right there. Okay, let me give you a definition. Let me erase that. Coterminal angles, or a coterminal angle, a coterminal angle is an angle, obviously, that is equivalent to another angle. Now that's kind of a vague definition, but essentially, let me give you a demonstration of what it really means. If I have a 1 degree angle, it's the same thing as let's add 360, it's the same thing as a 361 degree angle. Let's add 360 again. It's the same thing as a 721 degree angle. All these are coterminal. Co together, terminal means they end. So really the definition means they end in the same place. They end in the same place. So a more technical definition, which I'm just about to write, is they have the same ending ray. And ray meaning one of these little sides with an arrow on it. So we end in the exact same place. Now, we could continue to add 360 if we wanted to, and we could make these all day long. I mean, it goes on forever. Looks kind of like a sequence to me. And we can go backwards with it, and we can subtract. And when we do that, we wind up with some negative ones, negative 359, and it keeps going in that direction as well. So how do you find a coterminal angle? So for the next part, I asked that question, how do you find it? And we need to add or subtract 360 degrees until you reach, I'm going to get technical with the math, an angle, we'll call it theta, such that, okay, this is getting into some technical math language. We're going to reach some angle such that this is true. This statement right here, and you just saw this a minute ago, but what it means is we're between 0 and 360. It could equal 0, but it can't equal 360. Okay, there's some problems at the bottom of the page. I think they're pretty self-explanatory. There are a few problems at the top of the next page, or on the back. And it's true-false stuff and fill in the blank. I think it's pretty self-explanatory as well. There's another video that deals with radians, and it's also posted on the